Hi everyone, it's Miss Nergis again. We're having science lesson and I hope you guys doing really great and I hope you being safe and sound. I hope to seeing you as soon as possible. So let's get started. So today I'm gonna teach you Unit 5, Chapter 2, Lesson 2, page 222, which the subject is about light and color. And Unit 6, Chapter 1, Lesson 1, 2, 3, pages from 236 until 253. The lesson is about electricity and magnetism. Okay, so let's get started. Prism is a solid object that bends light. In another word, refracts light. The prism is refracting white light into a rainbow, which we call visible spectrum. All of the rainbow colors. Visible spectrum is all of the rainbow colors. So what is visible spectrum? It consists of red, orange, yellow, green, blue, indigo, violet. Okay. This is the main conception of making rainbow. How a rainbow is formed. How? How can we see it? Where does it come from? It's because of the water droplets. The same idea. Water droplets can act as a prism as well by refracting or bending the white light from the sun into visible spectrum so we can see all those beautiful colors. While sun is sending white light to us. Your eyes cannot distinguish between all of those colors until there is a prism. Water droplets can act as this prism. That's why you can see a very nice rainbow. Students, can you please do the chapter review? So whenever we come back to school, I'm gonna let you know about all of the right answers, but try to do them by yourselves. Alright, now let's go to Unit 6, Chapter 1. In this unit, we're going to learn about only Chapter 1, which is made of, consists of 3 lessons. Let's go to the first one. This chapter is all about electricity and magnetism. Lesson 1, page 236, Static Electricity. All matters are made of particles that has charge. Well, you guys know this, that all matters are made of particles. Okay, which are 2 types of charge. All those particles that is making up a specific matter has a charge. What is those charges? We have positive particles and negative particles. The positive particles are signed as a plus and negative particles are signed with a minus. Alright, now look at this picture. We have 3 materials or 3 objects. One of them has 4 signs of positive. One of them has 3 signs of positive and 3 of negative. The other one has only 2 signs of positive and 4 signs of minus. What is that? The first one is positively charged object, which means the number of the positively charged objects are more than the negatively charged objects. The second one is neutral object, neutral, which means the number of the positive and the negative are equal. The third one, which is the negatively charged particles, charged object, which means it has more, like this minus, it has more negative particles than the positive particles. Well, let me tell you about something. All the matters in nature, in real life, they are trying to be neutral objects. The positive ones want to equalize in their positive charge, and the negative ones want to equalize. They need an equalization. How this happening? How is this happening? Static electricity is the charge that stays on an object, like the balloon in your hair example, where the negative particles will leave your hair to the balloon. The negative particles, they're traveling from your hair to the balloon. That's why they seem like to be stick together. The doorknob shock. Have you ever tried to touch a doorknob, but suddenly a zap, like a current, comes into your body? Well, this is the static electricity which is happening to your body and the doorknob. The doorknob has many positive particles, okay? And your hand has many negative particles. Why? Because before touching this doorknob, you've been walking. You've been collecting negative particles by your feet to all of your body. So when they meet, zap, you'll feel the electric shock. And in this case, now they're equal in charge. Okay? Electric forces are the pulling or pushing of charged particles. Well, put this line in your mind. You should memorize this as your name. Alike charges repel and opposite charges attract. What does that mean? Look, positive and negative charges, they're attracting each other, while two positive charges or two negative charges, they will repel, pushing against each other. How can we see this in real life? This pushing and pulling stuff. Look at this picture of the balloon and a piece of cloth. The piece of cloth in the first part, it has like more negatively charged particles on it. But in the second one, it has more positively charged particles. So the balloon in both cases has negative charge on it. What is going to happen? The piece of cloth and the balloon, in the first case, they will repel, pushing against each other because negative and negative repel. But in the second case, they will attract and getting closer together because positive and negative get closer together. The electric shock that happens to you, to your hand, is also an electric current. A flow of electric charge, those charges are moving. Well, this movement, we can call it electric current, and it's measured in ampere. What is this ampere? You might have heard of this because the generator electricity that we're using in our houses, they're measured in ampere. For example, in my house, I have 4 amperes, which I can operate, or I can use it for operating the refrigerator, some lights, and the TV, and many other stuff as well. Okay, electric current in real life is used in circuit. What is the circuit? Circuit is a path that is made for an electric current. It's a path. Alright, guys, those charges, those positive and negative charges, do not move and walk just like us. They're not grabbing a taxi, of course. They need a special path for them, which we call it circuit. Okay? In a simple circuit, we should have a wire and a light bulb and a battery. Of course, a switch as well to turn on and off the light, just like how you turn off and on a light in your house. Well, this is all made of a circuit. The battery is the electric cell, the source of energy to keep the charge moving. Without the electric cell, no switch, no light bulb, no wire, no anything. Because electric cell is the most important thing in a circuit. Materials, according to their ability of transferring electricity, are two types: conductor and insulator. Well, electricity, for passing through a path, they need their special things, they need their special needs. They need a conductor to go on it, like to go on this path, and they also need an insulator. Why? To protect you. Because people who are working with electricity, like engineers, workers, or anyone else, even your father, your mother, when they're working with it, they need insulator. Why? Because this insulator can protect you and not getting an electric shock. Otherwise, you'll get an electric shock and you're gonna die. So, let's go back to the main point. The first type of material, which is the conductor, is a material that current can pass through easily. The current, the flowing of charge can pass through it very easily. Like what? Like silver, gold, copper, steel, and seawater. Even the tap water that you're using in your house. Number 2, insulator is a material that current cannot pass through easily. Well, insulator like what? Like rubber, glass, oil, diamond, and dry wood. Those insulator and conductor, both of them are very important in using your electricity in your house. Like, why? Why is that? Because look at this picture from the right. You see copper, which is the conductor part of a wire, and the plastic, which is the insulator part of the wire. You can't grab the copper just like that. You're gonna die. You're gonna get a very strong electric shock and you're gonna die. But you can hold the insulator, like the plastic part, very easily. Resistor. Resistor is a material that resists but doesn't stop flowing the current. In a circuit, this will cause heat and light. For example, the light from flashlight. You see this object? This is a picture of a resistance used in flashlight, which is heating up and shining. Resistor, the name comes from itself. It's resisting, like it doesn't let go very easily. It's still going, the current, well, the charge which are flowing, it's still going, but it's resisting, like a very bad guy staying in your way and say, hey, I'm not gonna let you go, but you'll survive, at least you'll go. So this resistance causes a very heating up and shining. This is the trick that we can have a flashlight. Alright, speaking of the circuit, we have two types of circuits: series and parallel. Series circuit is a circuit that has only one path for the current. So, look at the picture with me. In the series circuit, if you put your finger on one of the lamps, do you think the other lamp will lit? Of course not, because in series, if you take off one light, the other will not lit. You're gonna ruin the circuit. But in parallel circuit, what is parallel circuit? Parallel circuit is a circuit that has more than one path for the current. It could be 2, 3, 4, 10, 100, depending on the place where you put the light on. Now, put your finger on one of the lamps. Do you think the other one still lit? Of course it is. It's not going to be ruined. Okay, this is parallel circuit. Now, let's go to lesson 3, page 248. It's all about magnet. Magnet is an object that attracts iron and steel. Magnetic poles are the two ends of a magnet. You might have seen magnet, but you never realized why one of the sides is red and the other is blue. It's just to distinguish between the north and south pole. Magnetic field. Magnetic field is the space all around a magnet where the force of a magnet can act. You can see those lines by putting the magnet in an iron powder. Here we have the same idea. Like poles repel, opposite poles attract. Look, there are many similar things between electricity and magnet. Okay, like this one. In the electricity, we said that like charges repel, like the positive and positive, or negative and negative will repel, and opposite poles, like positive and negative, they will attract. It's the same thing here, but we're talking about poles, north and south. Well, magnetic field, if you look at the animated picture, as you guys can see, it's going from north to south. Those are imaginary lines. You can't see them, but only if you put the magnet bar in an iron powder. We have this in the lab, and I'm going to show you whenever we go back to school. Okay, so now look at the real pictures. The north and north pole, the two north poles, do not touch each other. They can't touch each other. Why? Because like poles repel. The other one, opposite poles attract. North and south pole, they attract. They line up with each other. We can have a magnet by rubbing a piece of iron in the same direction continuously. Well, this is pretty much easy. Whenever we go back to school, I got a bunch of plans on this. We can make this. It's very fun, it's very easy, and it's very full of information. If you want to have like making a normal iron, transforming a normal iron into a magnet, you can rub the piece of iron on a magnet continuously and in the same direction, not moving forward and back, in the same direction. There's another way we can have a magnet. We can have magnet by electricity, by using electromagnet. Well, guys, as I told you, there are many similar things between electricity and magnet. They look like a sibling, okay? They look like a very good sibling. Well, we can have electricity from electromagnet. What is this? It's a word combines of two other words. Electro, which means electricity, and magnet, it is meaning magnet, okay? Electromagnet is a wire, a conductor wire with current, okay, around an iron rod to make magnet. Well, it's pretty easy. You can do this at home. Go bring a wire, okay, and a charge. Why do you need this charge? To have the current in it. It's not coming from nowhere. It should have an electric cell, okay, a source of giving it current, a source of giving it flowing charge, okay. Make a coil, do some turns. The more turns you turn this wire on, the more turns you make, the more powerful magnet you will have, and you can use it. If you look at the animated picture, you see those blue lines. Those blue lines are showing you the magnetic field, the lines of the magnetic field, that you can't see it, but you can use it, okay? Electromagnetic cranes. You must have seen this in the movies. Are an obvious example of using electromagnets to have magnet. They're using a very giant coils, very giant electromagnets to make this electromagnetic crane. Compass. What is compass? Compass is a device used to know directions. When your compass points toward the south, you're heading to the north pole of the earth. Well, it's opposite of each other because the magnet needle in the compass will line up with the poles of earth. Like poles repel, opposite poles attract. Well, this line, you should put this in your mind because you need it a lot. Okay, in this unit, you're gonna need this a lot. Like poles repel, opposite poles attract. How is that? How can we use compass? Well, as I told you, it's used to know directions. If you put a piece of magnet next to a compass, you see that the poles are lining up like this. Pink, blue, which means north, north, south, north, south. Why the pink ones do not get combined together and the blue ones together? Why? Because the south pole, which is the blue part, is attracted to the north pole of the compass, which is the pink one. And of course, if you turn the magnet around, turn it around, flip it over, you see that the north pole will get attracted to the south pole of the compass, which is the blue part. Well, the same technique is used for for knowing the directions of Earth. If you're lost in a wood, if you're lost somewhere, you can use the compass. Well, for example, if the compass says you're heading to north, you're actually heading to south pole of the Earth. Okay, well, it's working in an opposite direction. So, I need you guys to do the chapter review. It's very important, as I'm always telling you. And thanks for the listening. Make sure that you have understood everything. Whatever question do you have, I'll be ready to answer all of your questions whenever school opens. And I'm hoping you a very healthy and enjoyable life. Please stay home. Do not go out too much. Thanks.